Hello everyone, my name is Srijan and I'm back with a new video. In this video, we'll talk about interfaces. So for the interfaces part, I've divided it into six subparts, and you can see in the screen declaring interfaces, implementing interfaces, multiple interface, type assertion, type switch, and embedded interface. So I've written the code for all the six parts. We'll quickly go through each and every example and look how it works and yeah, everything. So we'll just quickly start with how to declare interface. So this is the syntax, how we declare interface. Car is the name of the interface, and color and speed are the methods which are declared in the interface. In my main method, I've declared a variable of type car and I haven't assigned any value. So if I run this code, let's see what happens. See, you can see the value of the type car is nil, and also the type of the car is nil. Even though we have declared the type as car, it's nil. So here is something known as static and dynamic value. So its static value is car, which is the interface, but when I print the type of the car, it prints the dynamic value. So I haven't assigned any value. I can assign a struct or something, but I haven't assigned it, so it prints the dynamic value, and dynamic value is still nil. So this is the thing we need to keep in mind. What we are seeing here is the static value, but what we are printing here is the dynamic value, actually dynamic type. This is the dynamic value. So that's all for the how we declare interface. So for next, we'll quickly jump on to the interface implementation. So here I have written the code for multiple interfaces. Here is the same interface car with the two methods, and here I have declared one struct in which there are two variables, color value and speed value. I'll use this variable to print something out of this method, which to return something out of this method, which will be string. So here is how I will do it. I will implement those methods in interface in the struct. So this is the syntax how we implement methods. So here is the name of the method, type of the method, and this is on which struct I'm implementing this method. So for me it's Honda, and it's the type variable of the struct Honda. And see, you can see how I am using the variables in struct Honda in the method of the implementation. So this is the whole lot code of implementing the interface on a struct. And if I talk about the main function, it something looks like this. I have a variable car of type car, but I'm assigning it a struct value, so its dynamic value will now be a struct. And we will talk about struct in a later video. There's whole lot to cover in struct. So for now, I can tell you that to initialize a variable of struct Honda, this is a syntax how we do it. We specify the struct name and then pass two values which will be assigned to the corresponding variables, the color value and the speed value. So color value will be red and the speed value will be 240. So this is how we do it. So now our car variable has the instance of a struct which is Honda. So now if I print it, this is how it will go. Actually, I'm printing the car color and car speed. So yeah, you can see car dot color, which is the which is defined here but implemented here. I'm getting color of Honda car is red. The red value comes from here, Honda dot color value, which I have passed here. Yeah, and similarly the speed. And if you now see at the value of the car and the type of the car, now you can see the value is same as the struct because it has instant of the struct Honda. And if I talk about the type, so you can see the type is Honda. Though it is variable of a car which is interface, it has the type of a struct which is Honda. Type of a Honda of struct Honda which is struct. So in this implementation part, we'll take another example, which is how we can reassign the value car. Okay, so I've uncommented the code which I've written. So here I'm using another struct which is Hyundai. Actually in this video I forgot to mention one thing. This is, if something is you haven't seen that I haven't explicitly mentioned that Honda needs to implement this car interface. Yeah, here you can see it. There is nothing mentioned that color should be, or color is a function function of interface. So in Go, whenever a struct implements some methods which are already declared in an interface, it automatically implements that interface. So this is how it works. The interface has two methods declared, which is color and speed, and I have a Honda struct which I have using which I have implemented two methods, color and speed. It automatically implements the interface car. And there is a concept of empty interface. We'll talk about this later in this type switch. So for this, yeah, that's fine. So it automatically implements the desired interface. This is how it works. So in this example, I have uncommented the code of a new struct which is Hyundai, which also implements the interface car, because I have two implementation of the method color and speed. So automatically it implements the interface car. So you can see that to the same variable car which is of type interface, I am assigning the value of a type Hyundai. And if I run it, the output will be somewhat this. Yeah, the speed of the Hyundai car is this, which is I have reassigned it with 270 and this and that. And the type, you can see it's Hyundai, which is a struct, which is another struct type. So dynamically we can change the value type of interface by assigning it with a new struct variable. This is how it works in Go. Yeah, that's all for the implementation part of the interface. One more thing to mention is all the codes which I've written here are available on the GitHub. You can find the GitHub link in the description below. You can go to GitHub and just download it and just run it on your own if you want to do, or if you want to follow through the video, you can just first download it and then run it on your personal computer. So the next is multiple interface. In multiple interface, it's the same structure like the previous ones, but just one thing, which is I have divided the interface car into two interfaces, car interface 1, car interface 2, and also divided the methods. The color method belongs to car interface 1 and speed to interface 2. So this is the only change I have done, and rest of the code is same as before, as these classes, as these files. So how it goes like, so this Honda struct has implemented the method color, and this color is being declared at the interface car interface 1. So automatically Honda implements car interface 1. And similarly, for the speed method, it has also implemented the function speed. Car interface 2 is also implemented by Honda. So we can say this Honda struct implements two interface, car interface 1 and car interface 2. And same we can see here. I have made a variable of a Honda and assigned the type as Honda. And if I assign the Honda variable to a variable of type car interface 1, there will not be an issue, because this is known as polymorphism in Go, as object oops concept in other languages. The polymorphism looks like this in Go. So we can assign the variable, the value of struct Honda to the variable of type car interface 1, because it has implemented the interface. So on the later part, if I try to get the method, call the method of color on the interface 1 and subsequent method speed on the interface 2, it will not be an issue, because those methods belong to those respective interfaces. So we can see it works totally fine. And you can also see the type car object 1 and car object 2 has, even though they are variable of car interface 1 and car interface 2, both are Honda, because I've assigned the dynamic type and value as Honda. So this is all about multiple interfaces. Here the next thing we will look into is the type assertion, and here is an example. There's nothing different from the previous ones. I've just added one more interface to it, which is car interface 3, and it implements it declares a method mileage. So this interface will be used in the second part of the type assertion. In the first part, there's a simple example how to use type assertion actually. So this is used when you want, when two different methods are there in two different interfaces, and it is being implemented by a struct both the methods. So this Honda implements the car interface 1, car interface 2 both. So if suppose there was not the statement, there was this and this, so you can see here the car variable, which is of car interface 1, has a value of type struct Honda, and if I use it to call the method speed, it shows an error. This is because the variable is of type car interface and it does not declare the method speed. So for this I need to use type assertion, and what it does is converts the variable of car interface to a variable of type Honda, and gives the value of the same, which is here. So now if we run this example, it will look something like this. So you can see the type here is Honda, and the color it's fine, and speed it's working totally fine. So it's totally working fine. So in the next part, if we are going to see the how we can use type assertion in one more way, and that is by expecting a return value as well. So it works in the same way, but we are expecting one more error value as well. So it has the value of a boolean, true or false. If it is true, then the function totally worked well, and if it is false, then it generated some error in that function. So we'll just we'll just run the example and then go through the how it worked or how it didn't work. So here you can see for the first part it worked fine, that it showed some value, the error is true, it didn't generate an error. For the second, it did generate an error, which is the reason it is showing false here. So what are the difference in these two interfaces? So we will look above. Here interface 2 and interface 3, they have declared the method speed and mileage. So we can see the Honda struct has implemented the speed method, so it implements the interface 2, but it does not implement the function mileage, so it does not implement car interface 3. So Go compiler cannot figure it out whether car interface 3 is implemented by the Honda or not using type assertion if we see it. So this is thing which is find out at the runtime. So at runtime it struggled to find out an implementation of the method mileage in the struct Honda. So it just made an error in the function and just returned an error value. So that's all for type assertion. You can find out the code as I mentioned in the below description and run in your own computer, and then you can get more clarification about this. So next on we will jump onto the type switch. So for the type switch, we have one more concept before we just start with type switch. There the concept is empty interface. So empty interface is something. So we have discussed that the interface, if a struct has implemented one method which is declared in the interface, then it automatically implements the method, and this is for the case when it implements all the methods declared in the interface. Yeah, this is to keep it note that it should implement all the methods in the interface, then only we will say that the struct will has implemented the interface x or y or z. So let's talk about an empty interface. So empty interface is something which is by default implicitly implemented by all the all the types, we can say, not just the struct. So this is what happens if we just go to the print statement of FMT package. You can see it accepts an interface, and that too this function is a type which is known as variadic. So I'll just give you a short description of this. Variadic type is something which accepts unlimited number of variables of a particular type. So the type here is interface, which is an empty interface. So it is being implemented by all the types, so it can accept any type, and that to any number of times. So this is what it is used for. So that's the reason in the print function you can pass on anything. You can just keep on adding things, keep on adding things, keep on adding things. It will just accept everything because it accepts any number of variables, and that too of any type, because it is being accepted using the variable interface, which is an empty interface. So I have made use of empty interface here. For the custom print function, I'll just run it and then show it to you how the console output looks like. See, you can find it here. The custom print function is called, and the test, which is a string, is being passed to the empty interface I, which is this I is a variable of interface and but accepts a dynamic value of a string. So you can find the dynamic value is a string and the value as test, and similar for the float value, it's of type float 64 and value this. So we will quickly change the function which we are using, and then this is something which is specific to switch case. Yeah, so switch case, this is very specific to switch case. This syntax you cannot use anywhere else. This is very specific to switch case. So I'm getting a type variable of type interface, and this is the syntax in which I'll be able to extract the type of the variable, type of the value. Actually, type of it, the variable type is interface, but the value type, the dynamic value type is can be anything, like it can be string or integer or float, anything of any type, any derived type or as well. So to find out what is the type of that dynamic value, we can use the switch case and just extract the type using this statement, and this is very specific to switch case. You cannot even use it with if or something conditions. So if now I run this case, so here, so I have written this function to just adding custom print if the type is string. So if the case is string, I'm just using a different value, or else for every other type it will just print the normal thing. So this is all for type switch. Next on, we will jump on to the embedded interfaces. Embedded interfaces is like there is nothing like interface implementing another interface. So in Go, we use the term embedded interface. It This is something which looks like this is something which is embedded interface. There are two interfaces, interface 1, interface 2, and in Go, how we implement other interface, we cannot say it implement, but I'm using the word how the one interface implements another interface, because in other languages the same term is used, but here it is embedded interface. We can define two variables of we can say not variables, but I'm defining both the above interfaces in interface 3. So this is how we do it. And under this in this main function, if we see, I can get the value of the Honda variable in the car object 3 as well, which is of type interface, because by default, if Honda is implementing interface 1 and Honda is implementing interface 2, and since interface 3 1 and 2 are defined, Honda is by default in implicitly implementing car interface 3. So this is how this embedded interface looks like, and if I just run this code, it will work totally fine. Yeah, so it worked totally fine. The nothing else for embedded interface. If someone wants to go through the interface using the code, you can download the code in the given description, or you can go to the Go websites, or there are like tons of documentation available on the Google. You can just Google it and then find out more and more. So this is a very short video which went along, but yes, that's all. So I'll meet you in the next video.